Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have b plus 8 whole square is equals to 81, and we solve this problem for all the values of b. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method, and here our first method be the very straightforward or simple method. So here we move the term 81 from right hand side to the left hand side, and we get b plus 8 whole square minus 81 is equals to 0. So we rewrite this equation as b plus 8 whole square minus, this is 81, we write 81 as 9 square, and this whole equation is equals to 0. And now in the next step we need to just use here the nice algebraic formula here to simplify the terms. We know about that if you have x square minus y square equals to x minus y times of x plus y. So according to this nice algebraic formula, we expand the above equation as, so you see that the base of this term is our x and the base of this term is our y. So we just substitute the values of x and y into the right hand side of this formula, and this will be written as, the first factor is x minus y, the value of x is b plus 8 minus the value of y is 9 into, in the second factor the value of x is b plus 8 plus the value of y is 9, and this whole equation is equals to 0. So here we need to simplify the terms, and we add or subtract the like terms, and we have b into 8 minus 9 becomes minus 1, and b plus 8 plus 9 becomes here 17, and this whole equation is equals to 0. And now in the next step we divide this equation into the two cases. The first case is we write b minus 1 is equals to 0. The second case is we write b plus 17 is equals to 0. From here we easily get the value of b is equals to plus 1, and from here we easily get the value of b is equals to, we move plus 17 to the right hand side and we get minus 17. So here we get, these are the two roots of the given equation which we get here from first method. And now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So here for verification of this value we need to copy down given question statement. Here it is b plus 8 whole square equals to 81, and in this side we verify b is equals to plus 1, and in this side we verify b is equals to minus 1. So here first we verify b is equals to plus 1, and for this we substitute b equals to plus 1 into the left hand side and we check its behavior. So we get 1 plus 8 whole square is equals to 81, and we have 1 plus 8 becomes 9 square equals to 81, and we know about that 9 square becomes 81 equals to 81. This shows that both of the sides are equal. It means that the value b is equals to 1 is satisfied our given question statement. And now in the same pattern we verify the second value of b, and we put this value of b here, and we get b plus 8 whole square is equals to minus 17 plus 8 whole square is equals to 81. Further we have minus 17 plus 8 becomes here minus 9 whole square is equals to 81. So here you know about that when we take the square of negative term it will always gives us the answer in positive form. Okay, so minus square becomes positive and this 9 square becomes 81, equals to 81. This shows that both of the sides are equal, and if both of the sides are equal, this concludes about that the second value of b is also satisfied our given question statement. And finally, we have the solution set of the given question is b is equals to 1 and minus 17. So this is our final answer which we get here from first method, and now we again solve this problem for second method. So for second method, we need to copy down given question statement here, and the given question statement is b plus 8 whole square is equals to 81. So this is the our given question statement, and here our second method with a very straightforward or quick method. We quickly determine about the solution set of this problem. So here we use this the other nice algebraic formula, and you know about that. If we have x plus y whole square is equals to x square plus 2 times of xy plus y square. According to this nice formula, we expand the left hand side of the above equation as we write b plus 8 whole square as b square plus 2 times of b into 8 plus 8 square is equals to 81. And now in the next step we have b square plus 2 times of 8 becomes 16 times of b plus this 8 square becomes 64, and this is equals to 81. And further in the next step we move the term 81 from right hand side to the left hand side, and we get b square plus 16b plus 64, and this plus 81 becomes minus 81, and this whole equation is equals to 0. And now in the next step we need more simplifications here, and we get b square plus 16b and 64 minus 81 is equals to minus 17, and this whole equation is equals to 0. So you see that this equation becomes in quadratic form, and here we make the factor, we use the factorization technique to solve this problem. So for this we break its middle term, and we write this 16b as b square plus 17b minus b minus 17, and this whole equation is equals to 0. So here we take common b from here, and when we take common b, we get the remaining values are b plus 17, and from here we take common minus 1, then we get the remaining values are b plus 17, and this whole equation is equals to 0. And now here we take common b plus 17 from here, and we get the remaining values are b minus 1, and this whole equation is equals to 0. So we divide this equation into the two cases. The first case is we write b plus 17 is equals to 0, and the second case is we write b minus 1 equals to 0. From here we get the value of b is equals to minus 17, and from here we get the value of b is equals to 1. So you see that in the second method we again get these two roots of the given equation, but in the first method we already verified that both of these two roots satisfied our given question statement. So finally we have the solution set of the given question is minus 17 and 1. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.